In this video, I'm going to discuss how I went from taking a reading from the line sensor and converting it into a number that was used in the program. So first we start off by declaring a variable. And here I'm declaring the variable as a byte. And as we remember, a byte consists of 8 bits. So we have got 8 spaces that can either be a 0 or a 1. And if we can also remember a byte, the maximum value for a byte is 255. Very pretty. Okay. So I have my variable called line sense. I've declared it as a byte, which is 8 bits, and then I initialize it by making it 0. The reason for initializing the variable is because when the microcontroller starts up for the first time, sometimes we don't know what the condition of our variables are. So it's best to start them from a known state. Okay, and then this block of code actually runs in a continuous loop. So I only extracted or copied this block of code out of the program just to discuss it. So it runs this block of code, and then the rest of the program follows, and it gets repeated again and again. Right. So we are all very familiar with read ID, which is read the analog sensor, and we are also familiar with if. So in this case, with my alphabot, it was calibrated that if the analog sensor reads a value that is bigger than 500, it means it has detected a line. Now, what I said in the previous video is when I detect a line on the line sensor, I will set a bit in a binary number. So how do we go about setting that bit? It is by doing bit addressing. Now, you might remember when we want to turn a light on or off, or in the previous videos we wanted to turn a motor on and off, we would say set port C.1 on. So what's happening here? Port C is actually an 8-bit port, and we are writing a 1 to the first bit of that port. So we are actually doing the same with this variable. Just to give a bit more clarity, a binary number, and in this case an 8-bit number, has got 8 places to store a 0 or a 1 or an on and an off. The highest bit with the biggest value is called the most significant bit, and the lowest bit with the least value is called the least significant bit. So if we set this as a 1, this bit, then it's actually 1. But if we set this bit as a 1, it will be something entirely different. I'm not exactly sure how much it is. So what we are doing here is, if my line sensor that is connected to AN4 detects a line, I go and I say line sense, which is this variable here that I declared as a byte, the first bit, which is this one, I'm going to set that as a 1. If I look at the second reading, AN5, so I have connected the line sensors in such a way that they follow each other in a logical fashion. So if there is a change in the hardware, then obviously the software would have to change. So in this case, the hardware correlates directly with the 3 line sensors 4, 5 and 6, or maybe 4, 5 and 6. I can't remember the way I put them in, but you have to keep in mind which is which. So the way I put them is that they do follow in a logical fashion. So here, if this one reads a value higher, then I am addressing bit 1 here, and I'm setting that as a 1. If it is not, let's say this one here, it is negative, then I'm going to set the second bit as a 0. This last step is, I don't know if it's superfluous or not, or this else here, because I do clear line sense in the beginning, but I think it's best if you stick with making sure that if it detects the line, we set the bit. If it does not detect the line, we don't set the bit. And that's pretty much that. There's really nothing more to it. This is my variable. This is the bit that I am talking to. And this is either setting it a 0 or a 1. The same with this. This is my bit that I'm talking to, and I'm setting it a 0 or a 1.